All right, so on Friday and Monday, we talked about the difference between the two major kinds of probability, one being an or statement and one being an and statement. Remember, if it's an or statement, you have to check to see if things are mutually exclusive, and if it's and then you'd add them. If it's an and statement, you look for independent, and then you multiply them. So all of these are or statements. We'll get to some and statements today, but it says a card is randomly selected from a standard deck of 52 cards. Find the probability of the given event. So number 3 says a 5 or a face card. So this is again an or. Is it possible for something to be both a 5 and a face card? No, so these are mutually exclusive. And so for these, I simply just add the two probabilities. So I find the probability of picking a 5 and I add it to the probability of picking a face card. There are 4 5s, so it would be 4 out of 52. And there are 12 face cards, so 12 out of 52. You can either reduce that and then simplify, or you can add and then reduce. It doesn't matter which order you do this in. So 4 goes into both of these. This would be 4 and 13. Number 2 says selecting a face card or a diamond. Is it possible for it to be a face card and a diamond? Yes. So I do the probability of the face card plus the probability of the diamond minus the probability of both. So again, face cards, we know there's 12 out of 52 face cards. There are how many diamonds? 13, or 4 out of 52 if you reduced it. And how many are both a face card and a diamond? 3. There's 3 face cards in each suit. So this is 25 minus 3, which is 22 over 52, or 11 over 26. Number 5 says select an ace or a 9. Can it be both an ace and a 9? No. So there are how many aces?
1 or
4. 4. And there are how many 9s?
1.
4. And again, we can either add and then reduce. So 4 goes into this and into this. Or I could have reduced to 1/13 and 1/13 and then added. How you do that's completely up to you. On the last one, a 10 or a diamond. So can it be a 10 and a diamond? Yes. How many 10s? 4. How many diamonds? 13. How many 10s that are diamonds? 1. So 17 minus 1, 16 over 52. And we already simplified this, 4 over 13. So when you're building your review, your reference sheet, whatever you need for Friday, I would obviously recommend that picture of the deck of cards if you don't know it well. And I would recommend adding on the little box that we went over on Monday of the sum of the die, okay, because you could have a question on some of that stuff. The hardest part of this test is trying to make the questions between the class periods equal in difficulty, but also completely different. Like I'm not going to give you guys the same question as I'm going to give J period as I'm going to give C period, but I'm trying to level off their difficulty, if that makes sense. So you might get a card question, another one might get a rolling of the die question, somebody else. So there's a bunch of probability questions, not just one, but realize that they won't be exactly the same, but I'm working hard to get them to be on level. So through this review, and we won't work through all of it, especially because today's a shortened class period, but I will post this as completed. My goal with you today is to find out what of this you need me to review the most. So I'll talk about the concepts first, and then we'll go back and work out the ones that you know you need. But also, I have this completed already. I'll post it as completed. So we're going to do a quick overview of each of the sections, and then, like I said, I'll come back. So this is 8-1, and 8-1 was the sequences. This is what was on your quiz. So in 8-1, there's only going to be one sequence question. You could get a sequence question like find the first blank amount of terms, and it could be a regular sequence, it could be an arithmetic, it could be a geometric, it could be a recursive, okay? But it's on the module, all the way at the bottom. Okay, so number 1, and I actually changed it to 4, like the ones that are on your test are 4 because you know what you're doing. I just wanted to see a couple, and I don't need to spend 20 minutes plugging in numbers, okay? I will tell you that the most common mistakes made on the quiz were with the recursive. Remember recursive, you have to use the answer from before. Again, people did not do that. They were like plugging in 1, 2, 3, 4. Don't do that for recursive. You're using the answer from before. And also with recursive, forgetting to include the first one. So that's like this one. okay? If I plug in 5, I'd get, 5 is the first one. Then it's 2 times 5 minus 3, which is 10 minus 3, or 7. Then it's 2 times 7 minus 3, or 14 minus 3, which is 11. Then it's 2 times 11 minus 3, which is 22, minus 3, which is 19. So then the answer is 5, 7, 11, and 19. No spaces in your answers. You guys create extra work for me, and that's why it takes longer to get these answers, these test and quiz grades back for you. No spaces in your answers, the entire test. So that I would say people forgot to do this one, and or they plugged in 1, 2, 3, 4. Remember, if it's recursive, you'll see the word recursive, or you'll also see the k plus 1. That's when it's different. Brian, you had a question?
Mine's different.
Does it? So if I do it by plugging in, I'd start at the bottom, I'd stop at the top. So 0, 1, 2, and 3. If I'm doing it with my calculator to check, not all of them have it, which is why I'm asking for the work. So math, 0 is the summation on the math. And then I'm going to plug in x. It's going to be 0 here. Go to the top, it's 3. Go to the right, it's 2 to the x. Oh, I am, but I'm not. Hang on. Hit enter, and you get 15. Let me see if I can play that back. All right, then factorials came into play in these sections. So remember, factorials, we use them a lot after. But you also learned how to simplify back here. So if it was n plus 2 factorial over n, remember we want to count down from the higher one. So what's bigger, n plus 2 or n? N plus 2. So I would do n plus 2 times n plus 1 times n factorial over n factorial. These are going to cancel. And then my answer would be n plus 2 times n plus 1. I'd multiply that out. N squared plus 3n plus 2 would be the result. There are going to be answers in which you answer on your answer sheet, like your expansion you're going to do on your answer sheet, that kind of stuff, but the rest of it you'll type in your answers. Those of you that are physical here with me, you'll get the paper. Yay.
Just for being here, we get that bonus.
Just for putting, yeah, you have your camera on right now.
Yeah.
Starting next week though. All right, then came arithmetic sequences. These are the ones in which you're adding or subtracting the same thing each time. So this one just says write the first 5 terms of the sequence, determine whether it's arithmetic, and if so, find the common difference. So if I plug in 1, I'd get 3 times 1 plus 2, 3 plus 2, which is 5. I plug in 2, 3 times 2 plus 1, plus 2, sorry, 6 plus 2, which is 8. I plug in 3, 3 times 3 plus 2, 9 plus 2 is 11. I plug in 4, 3 times 4 plus 2, 12 plus 2, 14. And the last one, A5, 3 times 5 plus 2, 15 plus 2, which is 17. So the first 5 terms, which again I shortened to 4 on your test, are these, okay? Are they being increased or decreased by the same number each time? Yes. What would D be? So it's yes, it is arithmetic. What's D? 3. And so if I wanted to write, oh, that's all it said, right? Determine the common difference. That's it. Okay, the formula for A sub n is one of the first things you had to learn formula-wise. And AN is A1 plus D times n minus 1. And this is for arithmetic. So if you want to shorten this, if you want to compile it into one page, I would probably recommend it, of just your formulas and your cards and your little dice box. I would try to do that instead of flipping through all of this stuff. You can also have this if you want, but obviously the least amount of stuff you're digging through, the better. Most of you did fine on that one on the quiz. Is everybody okay if I skip that for now and keep going? Okay. Then first 5 terms, I would take that 4 and just keep subtracting 2. So just be careful there. Make sure you include 4 as part of your terms. Then came partial sum. So partial sum comes this is only for arithmetic. So for these, it's n over 2 times a1 plus an, or n over 2 first plus last. So in this example, how many terms are there? 121. Remember, it's top minus bottom plus 1 if the bottom is not 1. If the bottom is 1, then it is just the top number. But this would be 121 over 2. The first, I would plug 0 in. So 2 times 0 would be 0. The last, I would plug 120 in, and it'd be 240, sorry. So I do 121 over 2 times 240. Or 60.5 times 240, which is 14,520. Now format on any answer that's bigger than 1,000. I gave you with the comma and without, so it doesn't matter how you enter that. And again, I can check this with my calculator, but I'm going to make sure I have the word.
Is there going to be fractions, or will these like be whole?
There could be fractions. Yeah, sure. All right, then came geometric. So geometric, this is like find the first 5 terms. So we found the first 5 terms by multiplying when it's geometric. So for that first example, I would take A1, I'd multiply it. So A2 would be 2 times 1/3, and I'd get 2/3. A3 would be 2/3 times 1/3, and I'd get 2/9. A4 would be 2/9 times 1/3, and I'd get 2/27. A5, 2/27 times 1/3, and I'd get 2/81. That's the first 5 terms. So 2 is part of it. It would be 2, 2/3, 2/9, 2/27, 2/81.
So A2 is 2 times 1/3.
Right. You start with A1 and then multiply it times 1/3.
Oh.
So if you want to find the nth term, which is the second part, and it's geometric, that's an equals a1r to the n minus 1. So this would be an equals a1, which is 2, r, which is 1/3 to the n minus 1. That's your expression for the nth term. Then find the indicated term. I want to find a8. This would be 2, 1/3, 8 minus 1. That'd be 2, 1/3 to the 7th. You're going to keep this exact. So 3 to the 7th is 2,187. Multiply it times 2, and I get 2 over 2187. Okay, then found the one that you had to jump. So these were meh on the quiz. Like either you got it easy or you were a little all over the place. If I don't give you A1 and R, then you have to figure out what R is by working backwards. So in something like this, we would put A7 on the left. We put the bigger one on the left. A3 on the right. And then R has to be raised to what exponent? 4. It's the left side minus the base, or it's the 2 on the right have to add up to the left, however you want to look at that. So A7 would be 80 over 27. A3 is 15, and then I don't know R, so it's R to the 4th. I divide both sides by 15 or multiply 1 over 15. 5 goes into both of these. 3, it's hard to read, sorry. 3 and 16 times, and I end up with 16 over 81 equals R to the 4th. Find that 4th root. 4th root of 16 is 2. 4th root of 81 is 3. That will always be able to be simplified. It's not going to give you like a root that's not able to be 4th rooted or 3rd root or whatever. Now an would equal A1, which is I don't even need the A1. I'm looking for the 9th term. So I can go from the 7th term, A7 equals, I could go from the 7th term. So A9 equals A7 R to the 2nd, or I could say A9 equals A3 R to the 6th. You could use either one. So let's just do the 7. It'd be 80 over 27 times 2/3 to the 2nd. 80 over 27 times 4/9. And you'd get 320 over 27 times 9, 243. You'd get the same answer by doing A9 equals A to the A base 3 R to the 6th. You should get the same answer. Okay, then came the geometric sums, and remember there was 2 kinds. The first is finite. For this one, we do A1 times 1 minus R to the n over 1 minus R. Finite meaning I have an n at the top. It's not infinity at the top. So for the example that's there on the left, what's A1? -1. Okay, it's what's not being raised to the power. What's R? 1/3. The thing being raised to the power. What's n? 6, because the bottom is 1. So I'd get -1, 1 minus 1/3 raised to the 6th power over 1 minus 1/3. 3 to the 6th, I get -1, 1 minus 1 over 729 over, this is 3/3 minus 1/3, which is 2/3. This becomes 729 over 729. -1, 728 over 729 over 2/3. Keep, change, flip. 728 divided by 2, 364. And then 729 divided by 3, 243. And then just make it negative. So one of the mistakes made on this kind of question on the quiz was forgetting to multiply by the A1 at the beginning. Don't forget it. Like people had it at the top and then lost it at the bottom. Just be really careful, don't forget it. And again, feel free to check that with your graphing utility, but I am looking for that work. Then came the infinite. What you eating, Gianna? Breakfast? The infinite sum is A1 over 1 minus R. The rule here is it cannot be done if the absolute value of R is greater than or equal to 1. So that whatever's being raised to the power has to be in between 0 and 1. It can be positive, it can be negative, but it can't be bigger than 1. So this one can be done, this cannot be done. This, the A1 is 1, so this would be 1 over 1 minus 2/5. 5/5 minus 2/5 is 1 over 3/5. Keep, change, flip. And it's 5/3. This cannot be done on your graphing utility. You can't type in an infinity. So just keep that in mind, or scientific. But those are the easy ones. So finite sum you want on your reference sheet, infinite sum you want on your reference sheet. If you want to include the note about when it can or cannot be done, feel free. Expanding the binomial, and this is actually where your test will start because I want all that work at the top, okay? These you're just going to have your answers on your answer sheet. You don't have to type anything in a Canvas. They're both essay questions, okay? But there's one of each. One where you have to expand it all the way, and then one where you have to find the specific term. So remember, the expanding has 3 parts. It has the C's, It has the first term starting at the highest exponent working its way down, and the second term starting at 0 working its way up. So if I have something raised to the 4th power, how many terms is my answer going to be? 5 terms, right? My n is 4, but there will be 5 terms. So if I did 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, this is the row I'm taking for my coefficients. I would obviously recommend the Pascal's triangle over having to find C40, C41, C42, C. It just takes too much time. You might as well write out your Pascal's triangle on your reference sheet. And then if by chance you get something that's too high and you don't have it, you could always add your rows on, okay? So my first leading coefficient, or the binomial coefficient, is 1. Then I grab the first term, which is 3 to the x, and I raise it to the highest exponent, which is 4. Then I grab the second term, which is a negative y, and I raise it to the 0. Then add to it. Now my coefficient is 4. First term, 3 to the x to the third. Second term, negative y to the first. Then I add to it. Now my coefficient is 6. First term, 1 less is squared. Second term is now squared. Then I add to it. Back to the 4. First term, 3x to the first. Second term, negative y to the third. And then I add to it. The last coefficient is 1. First term, 3x to the 0. And then negative y to the fourth. Feel free to do that in any order you want. So some people like to do all the c's, and then all the first terms, and then all the second terms. That's totally fine. And if you know that something to the 0 power is 1 and you don't want to include it, it's fine. But this step has to be there. So again, your work has to show this step. Now your calculator can do the exponent work for you, okay? But that step has to be part of your work. So I get 1, 3 to the 4th is 81, x to the 4th, negative y to the 0 is 1. Then I get 4, 3 to the 3rd is 27, x to the 3rd times negative y. Then I get 6, 3 to the 2nd is 9, x to the 2nd, negative y to the 2nd is a positive y to the 2nd. 4, 3, x to the 1st, negative y to the 3rd is a negative 3 y to the 3rd. And then 1, 1, and y to the 4th. Then we multiply it out. So 81 x to the 4th. 4 times 27 is 108, and there's a negative here, so negative 108 x to the 3rd y. 6 times 9 is 54, x squared, y squared. 4 times 3 is 12, but there's a negative there, so negative 12, x, y to the 3rd. And then a positive y to the 4th. So this one, remember there's a little bit of work obviously here. This one's 10 points, the rest of them were 6. I think there ends up being 16 questions, something like that.
Do we need to show that second line? On the board or not?
As long as you have the first, I'm good. I would do the second just because I think it's easier to make sure that you don't make a mistake. But work-wise, I won't take points off if you don't have it. Okay, then finding the specific term of something that's raised to a power. And this is another formula you want to include. So it would be CNR. A, which is the first term, raised to the n minus r. B, which is the second term, raised to the r. And remember, the r is 1 less than the name. So if I said find the third term, what is r? R is 2. What is n if it's 2x minus 5 to the 7th? Good. Always the exponent, so n is 7. So I have to do C7, 2. First term, which is 2x, to the n minus r, which is 7 minus 2. Second term, negative 5y. You got to include that negative. R, which is 2. So I'm going to let my calculator do the work for the C7 too, because it's going to save me time, and your teacher's going to let you do it. Remember, that's under your probability menu, depending on what calculator you have. Make sure you know how to plug that in. That's 21. This would be 2x to the 5th, negative y to the 2nd. 2 to the 5th, 32. X to the 5th, negative 5 to the 2nd, 25, and then y to the 2nd. So 21 times 32 times 25 is 16,800. X to the 5th, y to the 2nd. And again, I gave answers with like thousands in them, with a comma and without. So you could type it either way. Good morning. Mm-hmm.
Would this type of problem be like find like what you said there? Would it be like a word problem?
No, it's going to say it just like that. Find the whatever term of this expansion. Yep. So that, like if you're getting your brain ready for order, that is 1 and 2 on your test. And then it gets into the 8, 1, 8, 3, and then it gets into the probability. So, okay, then came 8, 5, which is like the start of the probability. This is where we figured out how many ways something could happen. So in this section, you had to figure out if order was important or not. And that was the difference between the permutation and the combination. So permutation, order matters. And the combination, it doesn't. So for the first one, it says, how many ways can a computer randomly generate 2 integers whose sum is 10 from a set of numbers 1 through 10? So if you're just doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, from 1 through 10 includes both of those, and you're just trying to get the sum, you can start high. So 10 in a number doesn't work, but 9 and 1 works. So I could do 1 and 9, and then you could also do 9 and 1. And then I can do 2 and 8, and I can do 8 and 2. I can do 3 and 7 and 7 and 3, 4 and 6 and 6 and 4. And then you can also do 5 and 5. So first time you can pick 5, second time you can pick 5. The next example says, how many ways can a computer randomly generate 2 integers? And this says distinct integers. So remember, distinct means they can't repeat. So we basically don't include that 5 and 5. So for the first one, my answer was 9 ways. The second one, my answer is only 8 ways. A sandwich shop has 3 types of bread, 4 types of meat, and 2 types of cheese. How many different sandwiches can be ordered? So these are each individual events. One is the bread, one is the meat, and one is the cheese. If you want to figure out all the different combinations, you're going to multiply out the number of possibilities for bread times the number of possibilities for meat times the number of possibilities for cheese. So 12 times 2, which is 24 different ways you can build a sandwich. A student number is a 6-digit number. How many numbers can be created? So in this case, you've got 6 one-digit numbers. It didn't say anything that they couldn't repeat. So from a one-digit number would be from 0 to 9, which means there's 10 possibilities, 10 possibilities, 10 possibilities, 10 possibilities, and 10 possibilities, or 6 followed by 6 zeros. 6 million different possibilities. If it had said something like it couldn't repeat, then this becomes a permutation. If it had said something like it couldn't lead with a 1, then you would eliminate one of those digits from the front like we did with the phone numbers. How many ways can 13 kindergartners be arranged in a single file line? This is a case in which order matters. So this is going to be a permutation of those 13. So 13 factorial, which you can either do 13 times 12 times 11 or work your way all the way down. That would be a lot. Or find the probability button on your calculator, which has the exclamation mark. 6,227,020,800 different ways 13 kids can be arranged. That seems ridiculous. Find the number of distinguishable permutations of the group of letters. So distinguishable means that we have to pay attention to ones that repeat. So in the numerator goes 1, 2, 3, 4, 5, the total amount of letters. In the denominator goes the ones that repeat. So I don't need A because that would be a 1 factorial. L, that would be a 1 factorial. E, 1 factorial. But there's 2 P's, so this would go over 2 factorial. So 5, 4, 3, 2 factorial over 2 factorial. And I'm just multiplying these out. 20 times 3, which is 60. And 8-6, what's the probability of rolling an even number on a 12-sided die? So a 12-sided die obviously goes from 1 to 20. And 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 are all even, which is half of my die, 10 out of 20, or 1/2. What's the probability of selecting a jack or an even numbered card? This is an or, so now I have to say, are these mutually exclusive? Can it be a jack and an even number card? It can't be. So I just want to find the probability that it's a jack plus the probability that it's even. There are 4 jacks out of the 52 cards. And there is a 2, a 4, a 6, and an 8. And a 10. So that's 5 of each, and 5 cards, 4 of each suit, which means there's 20 even numbered cards. 24 over 52. 4 goes into both of them. That's 8 over 13. Next up, what's the probability of selecting a jack or a heart? So again, but it's a jack and a heart. It is possible to have a jack of hearts. So we need to do probability of jack plus the probability of the heart minus the probability of the jack that is a heart. Probability of jacks, there are 4 jacks out of 52. Hearts, there's 13 out of 52. And a heart that is a jack, there's 1. So that's 17 minus 1, 16 out of 52, or 4/13. And the last one, if you select 2 cards without replacing the first, so without replacing is obviously important, what's the probability that you'll select a face card and then a 4? So an and means multiply, and we have to figure out if it's independent or dependent. Because you don't replace it, this is dependent. So it's the probability of picking a face card times the probability of picking a 4 given a face card is already gone. So there are 12 face cards out of the 52. If you took a face card the first time, there's still the same amount of 4s left. There's still 4 4s, but there is 1 less card in my deck. So this would be 3/13 times 4 over 51, and then you can actually reduce it one more time. 3 goes into 51 17 times, and I get 4 over 13 times 17, which is 4 over 221.